Hello friends, welcome to my channel. In this video, I will explain you the concept of perfect frames, that is the introduction to frames. Let's start. The list of topics covered in this presentation are: what is a frame introduction, classification of frames, pin jointed and rigid jointed frames, perfect and imperfect frames, plane frames and space frames. These are all the classification of frames. We'll discuss about those frames in detail in the next slides, and in the last we'll see the applications and practical examples of the frames. So watch this video till the end. What is a frame? Definition: a structure made up of several members connected together at their ends by riveting or welding to resist the external loads. These are known as the frames or a frame structure. The members used for the frames are angles, channels, pipes, etc. The place where the members are jointed are known as nodes, and all nodes and all the loads act at the nodal points. The members of the frame are subjected to only axial forces only. Axial forces either tensile force or compression force. See guys, these points are known as the nodes. The joints are node at these members are connected to these joints. These joints are known as the nodes. If all the members of the rigid frame are constructed by frictionless pins to form triangles, then it is known as the trusses. Some frame examples are given to help you understand the concepts: king post, double fink, inverted queen post, double how, piggyback, fink, how, hip, studio, scissors, fan type, monopitch, cathedral, modified, coffered. These are all the various examples of the frames. Examples we use during the constructions design purpose. We'll use these different types of frames for practical applications based upon the requirement. These are all the various types of the frames. Now coming to the types of frames. Generally frames are classified in different types. Among those types, based upon the type of joint, the frames are classified as pin jointed frames and rigid jointed frames. We'll see what is a pin jointed frames and what is a rigid jointed frames. In pin jointed frames, the joints are connected by the pins. The members are connected by means of pin joints. Pin jointed frame structure may be defined as a structure built up of straight members connected together at their ends by frictionless pin joints, as you can see in the figure. These frames support loads by developing only axial forces only. These will take only axial forces, either tensile force or compression force. Pin joints in trusses can transmit forces but do not transmit the moments. So members in pin jointed frames do not bend. The angle is free to change during the loading. As you can see in this figure, these members are connected together by pin joint. Here in pin joint, the trusses will take only axial forces only, and the angle between the members doesn't change during the loading. And now the second type, rigid joints in frames can transmit forces and moments, so there is bending in members. Angle between the members remain fixed in the members. As you can see in the figure, this is welded together and this joint is a rigid joint. The angle between these two members doesn't change. Rigid joint members are connected by means of rigid joints. The angles between the members do not change. The frame resists the external forces by developing bending moments, shear force and axial forces and twisting moments. As you can see in the figure, these joints of the frame are connected by rigid joints. That means the angles between the frames doesn't change after the loading. This is a classification based on the types of connection, that is either pin joint or rigid joint. And coming to the next classification, Based on the dimensions of the frame, it is classified into two types, that is plane frames and space frames. Plane frames, the members of the plane frame as well as external loads are assumed to be in one frame. That is 2D frame. The example you can see that is in 2D. Now coming to space frames, the members of the frame do not lie in the same plane. It is a combination of series of plane frames. It is a combination of series of plane frames. This type of frames are known as space frames, 3D frames. Classification of frames. We have seen that the frames are classified into pin jointed frames and rigid jointed frames. In pin jointed frames, you have two types, that is determinate frames and indeterminate frames. We'll see in the next slide what is a determinate frame and what is an indeterminate frame. Again, these determinate frames are classified into two types, that is perfect frames and imperfect frames. This we'll discuss in the next slides. Again, these imperfect frames are classified into two types, that is deficient frame and redundant frames. All these comes under the category of pin jointed frames, that is determinate frames. Determinate whether it is a perfect or imperfect. Again, in imperfect, deficient and redundant. Okay. Now we'll see what is a determinate frame. The frame which can be analyzed by using the equilibrium equations, that is summation of all vertical forces equals to 0, summation of all horizontal forces equals to 0, summation of all moments equals to 0, then such type of frame is known as the determinate frames. Example, all perfect frames which have not more than two supports comes under the category of determinate frames. And coming to indeterminate frames, the frames which cannot be analyzed by using the three equations of equilibrium, that is summation of all vertical forces equals to 0, summation of all horizontal forces equals to 0, summation of all moments is equals to 0, then such type of frame is known as the indeterminate frames. If the frames having more than two supports and the frames with both ends fixed comes under the category of indeterminate frames. These are the categories of frames, whether it is determinate or indeterminate beam, which is helpful while solving the problems. Now coming to the perfect frames, classification of frames, whether perfect or imperfect. We'll see in this slide what is a perfect frame. If the number of frames are just sufficient to keep it in equilibrium without changing in the shape under the action of external load, then it is known as the perfect frame. It is the definition of perfect frame. The condition for perfect frame is m equals to 2j minus 3, where m is the number of members, j is the number of joints. This is an example. In this figure, you can see if you count the number of members here, 1, 2, 3, 4, 5, 6, 7. 7 members, and joints are 1, 2, 3, 4, 5. 5 joints. So we apply the condition m equal to 2j minus 3. We have to check whether the number of members and joints satisfy this condition. Substitute the value 7 equals to 2 into 5 minus 3. You can see that number of members is equals to the 2j minus 3. Hence the condition is satisfied. This type of frame is known as a perfect frame. That's it. Now coming to imperfect frame. If the definition is, if the number of members of a frame are not sufficient to keep it in equilibrium under the action of external loads, then it is called an imperfect frame. In the perfect frame, we have m equals to 2j minus 3, whereas in imperfect frames, it doesn't obeys the condition m is not equals to 2j minus 3, where m is the number of members and j is the number of joints. Again, these imperfect frames are classified into two types, that is the deficient frames and redundant frames. Now coming to deficient frames, if the number of members are less than 2j minus 3 condition, then it is known as the deficient frame. In the next slide, we'll see one example. See this figure, the frame, count the number of members, 1, 2, 3, 4, 5, 6, 7, 8. 8 members and joints are 6. Then you apply the condition m equals to j minus 3. After solving, you will get 8 less than 9. So it is a deficient frame. Number of members are less than 2j minus 3. It comes under the category of deficient frame. Now redundant frames. If number of members are greater than 2j minus 3, then such type of frames are known as the redundant frames. We'll see one example. This is given a frame, for example, number of members 1, 2, 3, 4, 5, 6. Total number of members 6. Number of joints are 1, 2, 3, 4. 4 joints. Apply in the condition m equals to 2j minus 3. Number of members 6. Joints are 4, 2, 4 is 6 minus 3, 5. Here are number of members are greater than 2j minus 3. So hence it comes under the category of redundant frame. These are all the general concepts in the frame, types of frames, example problems, so that you will understand the concept of all these types of frames. Now coming to the applications of frame, we use the frame structures for construction of roof shades, workshops, factories, industries, you may have seen, railway platforms, transmission line towers, and bridge trusses, etc. We'll see some practical examples of the construction of frames. You can see the trusses. Practical example of frames. Some are connected by joints that either be riveted connection or bolted connection or welded connection. If it is welded, then comes under the rigid joint. If it is connected by pin members, then it comes under the category of pin jointed frames. If it is a 2D, it comes under plane frame. If it is a 3D, it comes under the space frames. This is a truss span. Transmission line towers will be similar to this structure. This is a 3D frame. It is connected rigid jointed frame because it is not connected by pin joints. Another example, the bridge truss. You can see the bridge truss arrangement. These are connected by pin joints. If it is a pin joint, then it comes under the category of pin jointed structure. If it is a rigid joint, it comes under the category of rigid joint structure. That's it, guys. Hope you like this video. Thank you for watching. If you are new to the channel, just subscribe to my channel for more videos and updates. We'll see the assumptions in the truss and the various analysis of trusses in the upcoming videos. Thank you.